In this video, we're going to perform the statistical analysis to determine which of the golf ball brands are statistically different. We're going to use what's called the Tukey method, which essentially calculates a critical difference value between the four means to establish if we truly have statistical difference. I use a 7-step process. The first step is to confirm that the p-value is less than alpha, because it's important that we reject the null hypothesis in order to do this analysis. Step 2, we need to find the juncture of the mean square column with the within groups column. That's this number right here. You see they're the same. Basically, this is the mean square error term, and we will use that as we continue to work through our analysis. So we're going to calculate a margin, a standard error, which is the square root of this MSE term, mean square error term, and this is really the variation, if you will, within the four groups of golf ball data. And let me just come over to this graph and just show you what how the variances compare between golf ball A, B, C, and D. These are the four brands. These are the distances driven by the robotic driver. And looking at the scales, I think one can conclude that the variation is equal, which is one of the key assumptions. But always a good thing to visualize what your data looks like. So in order to calculate this standard error term, which is the square root of the MSE term, and let me do that again, equals square root, let's pick this term, and we'll divide that by the square root of n, where n is the number of samples for each brand, and that equals 10. Okay, so this is the equation and this is the number. So we do have we do have in step 3 number of treatments. We have 4 brands. That's golf balls A, B, C, and D. Step 4, the number of samples per treatment, N sub T, is 10. The V, or degrees of freedom, is associated with the within groups column within this MSE term, so that is 36. We go to a table in our book where we have this Q sub A term, which is the critical value of the studentized range. It is a similar statistic as maybe a T alpha over 2, but a little bit different. If you go in the book where K equals 4, V equals 36, you'll see a number. You'll have to interpolate between a degree of freedom 30 and 40, and I picked 3.81. If you multiply in step 5, where we are calculating a yardstick, we're going to multiply the standard error times this Q alpha term. And this 5.54, this is the critical difference value between the four means that we will use to establish statistical difference. So step 6, we need to now populate a table where we compute the differences between all the different means. So in this column, we're going to compute the difference between brand C and brand B, difference of brand C and brand A, and the difference of brand C and brand D. In this column, we're going to calculate the difference of brand B minus brand A and brand A minus brand D. And then here, we're going to calculate the difference between brand A and brand D. So now we have all of our mean differences calculated, And I want to check this number right here. This should be the difference between brand B minus brand D. Okay. So now, in step 7, we want to compare this yardstick or critical difference parameter with each of these differences right here. If these differences are larger than this yardstick, that means that there is statistical difference between the brands. So this term, this term, this term, basically all the terms except for, excuse me, all of these are greater with the exception of brand A and D. So basically what this says, that the mean, there is statistical difference at an alpha equal 0.5 exists between all brands except brand A and D. That concludes this video.